the recording from last time.
It did, but I was having to like splice the files together and time them properly because the audio started at a different time than the video. I gave up. It wasn't super important anyway. That was more like a practice run, so this one I'm just synchronized.
I'm so excited to hear what else going to be like, we're going to do a workshop
Okay, welcome back. Session 2. We're going to be going through a lab exercise today intended to familiarize yourself with how to work in R. Okay, so the RStudio interface and also some of the basic syntax for doing functions, mathematical operations, and reading data into the software. Just so you know, I am trying to record this, so I've got screen capture going on my laptop and my phone is recording my voice. I'm going to put these together after the fact and we'll see how that goes. Hopefully it works fine. So first thing you're going to need to do, ideally at this point everybody has installed and loaded the virtual machine at least once, or if not, you've at least got RStudio running on your local machine. Okay. The first few minutes are going to be spent assuming you have the virtual machine working. Okay. I'm going to be sitting a lot during this lecture. I apologize. It's just because it's easier for me to type. If you can't hear what I'm saying or see what I'm doing, feel free to interrupt, okay? So if you've loaded the virtual machine at least once, going through the instructions, recall that whenever you shut this thing down, you want to use the red X in the top left of the window, and it'll give you this prompt asking you, do you want to save the machine state, or there's a couple other options. You always want to close it, saving the machine state. Assuming you've done that, when you come back to your computer, what you're looking for to start with is an application that looks like this. It's the VirtualBox application. So if you're on Windows, you can go to your Windows start bar and you can type in VirtualBox and you should be able to find it somewhere like that. If you're on a Mac, it'll be under your applications folder. Right here, VirtualBox. Okay, so this is what I'm going to open. I've also taken it from the applications folder and just copied it into my dock down here to make it accessible for me. If you're a Mac user, you may want to do that. And when you open it, it'll look the same on both Windows and Mac computers. You should see something that looks like this. Okay? On the left is where it shows you different virtual machines that have been loaded previously. We should have one called Big Data. If you've gone through the instructions already, that should be there. All I do to reload it is I click it and I click Start. Okay. And it'll bring the virtual machine back up exactly in the same state it was in before, the last time I was using it. Anybody having problems so far? Yes?
I'm installing I was in the first session.
Okay. But you were getting the emails?
No, because I signed them yesterday.
Okay. Okay, you may want to try and sit next to somebody, just because we have a lot of stuff to get through in this class. If you can't get figured out, you can talk to me afterwards if you're having some error messages or anything. If your machine comes back up and it's showing a screensaver of some kind, like you just saw on mine, you can hit a key and it should bring back your desktop. Occasionally, when this window opens, you're going to get these alerts at the top of the window. You can generally ignore these and just close them by clicking the blue X. Okay. And what you should have is a desktop that looks like this. Okay, this is a Linux desktop. And what we're going to be doing, you will probably have this pane open on the bottom. Mine, I've set it up to be minimized, so just because I like it that way. If your screen resolution is not ideal for you, as I mentioned last class, you can go to View, Virtual Screen, and you can change it, play with these settings to make it something that looks better for you, okay? Okay. So we have RStudio here, right? R is also installed. You don't need an icon for it. RStudio will automatically access it for you when you load it. And you have your shared folder here, right? Which should be, if it's working, when you double click it, you'll see something like this when you open it. This is, again, the folder on your virtual machine that is shared with your actual host computer. So in this case, my Mac. So if I pull this window aside for a second, this is where I loaded the virtual machine. We have this big data box folder on the desktop. That's the exact same folder. See, it's got these two files. So anything I paste into this folder on my Mac will appear in the virtual machine and vice versa. So that's how I can move files back and forth between the virtual machine and my host computer. If you don't want to think about that, anything we do in this class, I'm going to be sharing the files on campus. You can just work inside the virtual machine, open a browser in the virtual machine, and download the files and things in the virtual machine. And then you don't have to worry about moving the files back and forth. I would suggest that just because it's easier. Okay. So the first thing I suggest doing is creating a new folder on the virtual machine desktop where you're going to keep track of all the stuff you're doing in this class. Okay. So I'm going to right-click the desktop and go to Create Folder. Okay. And call it something intuitive. So Business Analytics. Okay. Assuming that worked, you'll see a folder appear in the bottom left over here. I'm just going to move it up, click and drag. This is where I'm going to download things to, right, from campus when I'm working with files and stuff. So our lab exercise is on the campus website. It's shared there. So I'm going to open a Chrome browser. Right? It's actually called Chromium. Don't worry about the difference. It's basically Chrome. The logo looks the same. It's a circle, like a pinwheel. I'm going to click that from the bottom dock. It'll open a browser for me. Okay. And I'm going to go to the campus website, campus.ie.edu. Okay, and I'm going to go to our class. Maybe just forward her the email I sent you earlier.
Yeah.
Okay. And so I'm at our course, and then under additional documentation is where I've shared stuff for each session. Okay, so we have here session 2, lab, and homework. And essentially we have a number of data files and also the questions. There's a .r file here. That is an R script, which already has the answers to the lab questions in it that you can refer to. Okay. We have a .csv file, which is a comma-separated value file. It's basically a text file where it's got unique values separated by commas. There's an Excel spreadsheet, or a couple of them actually, and then a PDF file, which is the questions for the lab and the homework. So you're going to want to download each of these files and save them in that folder we just created. So the way I'm going to do that, I click the option. I'm going to say, or sorry, I'm going to right-click each link. So when I right-click, I'm going to go to Save Link As. And then I'm going to navigate to my desktop, to the business analytics folder I just created, and I'm going to save it there. So I'm going to do that with each of these files. If for whatever reason you've got these files on your host computer, you can just copy them over through the shared folder, open up the VM, go to the shared folder, and move the files over from there. Save link as. Right click, save link as. All right, so do this with all of the files and save them to that folder we just created. Okay, so it'll download each of these. They're not large files, so it shouldn't take very long. And after I'm done, I should have my folder I created with all of these relevant files in here. Yes, question. Okay, so have you loaded the virtual machine previously?
Yes.
You have. Okay, that's odd then. That didn't work.
I downloaded everything. Yes, it worked. I had the security thing.
Mhm.
I had to put my password and then say it was right.
And you clicked Vagrant, you typed in Vagrant up and loaded the virtual machine? Okay, because it should appear here if that's the case.
Because it's in French, so.
That's fine. Unless you don't speak French, of course, which makes it better. Where did you download it to? Yeah, so those you downloaded the bigdata.box file and the Vagrant file from
Yes.
the shared Google Drive.
Yes.
Okay. So if you follow the instructions, it asks you to create a folder on your desktop.
Yes.
Put those two files into that folder.
But you know also because I have this. They have the Vagrant, this one, VirtualBox, it's there. And you want those two files here?
Yeah, so you need to go through those instructions
Yes.
because that step is part of the
Yeah,
instructions.
but they told us like if I want to download them, like it's starts scanning for theirs and it's like too heavy for the computer.
So you say download anyway.
Downloading
It'll download those files to your downloads folder,
it. Okay.
and then you need to go to your So there's a video as well that shows you how to
No,
do it.
no, I saw the videos, but okay.
Well, you'll have
I can do it again.
the folder will be on your desktop at the end. So you can talk to me afterwards if it's
Yeah.
not. But I suggest watching on his screen if you can. So at this point, we should have a folder with these files here. So now what I'm going to do, I'm going to open the PDF file, which will by default open in Chrome. I think that's the only piece of software on the virtual machine that can handle a PDF file. Okay, and you'll see there's some preamble I've given you here explaining the contents. Everything highlighted in red is going to be a homework question, right, which will be due next week. So I'm not going to answer those questions obviously here, right? Those are the ones I'm going to skip over, and if we have time at the end, you can start working on those. Okay, everything in black we will go through here. I've also mentioned that if you want some additional exposure to how you should work in R or how to work with the syntax, there's a nice Udacity course that's free online, created by some folks at Facebook that you can go through, okay? At the end of the day, or at the end of, I guess, next week, what you're gonna need to submit back for the homework assignment is an R script, and I would suggest actually having a Word file, a Word document that goes with it, where you can explain not just the syntax, but also maybe some discussion about what you saw, paste a screenshot of the results when you ran a command, stuff like that, just to articulate what's going on as you go through and answer the questions. Recall that I mentioned you should be completing these homework assignments in groups of 2 to 3 students. Okay, so when you're submitting this thing back to me through Canvas, you want to make sure each student's name is in there so I know who's associated with what assignment. Okay. I'll show you in a moment how you'll create an R script. That's what the .r files are. One last thing I'll mention, and I'll show you how to do this in a second. You're going to want to heavily comment the R script. Comments are supporting texts that are not executable commands, but they explain what are you doing, what was your logic or your thought process. This is useful if you come back to these things later. You often, if you don't do this, will forget what you were doing and why. Trust me, this has happened to me many times, which is why I'm very good at commenting now. Okay, so first thing we're going to do, if you open up RStudio, so I'm just going to move this for a second. I'm going to open up RStudio. The RStudio environment looks like this. Okay, I've got three console windows, or three panes rather. Yours may look slightly different by default. I've got my console, and in the top right, I've got what's called the environment window. In the bottom right, it's showing me my file system. Just for the sake of consistency, if you want yours to look like mine, I suggest you go to the View menu and Panes, and then make sure it says Console is on the left. Okay, and then you won't get confused if yours looks different than mine. First thing that the lab assignment suggests we try doing, let me just go back to that PDF file. It says go to the console and try running this command, 3 + 2. So in R, I go to the console, which is the pane in the bottom left, and I just type 3 + 2, and the result is 5. So far, so good. Anyone having any problems so far, aside from setup?
I think I have to adjust the keyboard.
That's possible, yeah. By default, it may be a Portuguese keyboard or something.
Yeah,
So,
something weird.
so you can change your keyboard setting. If you go back to the desktop, there's this link called Keyboard. So double-click that, and then go to the Layout menu at the top, the Layout tab.
Yeah.
And go to Keyboard Layout. You may see a few language options there. So if it's not, change it to a language you prefer or tend to use, or whatever keyboard you'd like it to be. And then there's also keyboard model that you can change.
Yeah, I usually use the ABC chords.
Okay.
Well, I guess I do that in the keyboard model, right?
If you can find it there, yeah. So on a MacBook, this is easy because I know they have MacBook Pro, for instance. You can try a couple of different things. So it's basically certain keys are not mapped properly for you. If you're using so I would go to one of the Mac options.
That's for Apple laptop.
Yes, it's listed this way, MacBook.
MacBook. Okay.
Yes. And mine, actually, it's good that you did that because now mine's set up properly too. Okay.
That should be enough, right?
It should be, yes. So, go back to RStudio, 3 + 2.
Sorry to bother,
Yeah.
for the plus thing, I get a parenthesis, a square bracket.
So you're doing Shift plus, and okay. So yeah, your keyboard mapping is not correct.
Yeah, that should be an easy problem to fix. But
Yeah, but it's an important one.
yeah, because if I do this is what happens. So the numbers are correct.
Yeah.
But the signs are just now aligned.
Yeah, you're right.
Where did you do this one?
So if you have some was one.
Yeah, maybe international.
Still the same.
You need to get the right mapping, or it's going to create a lot of headaches later.
Yeah, that's what I was imagining.
Is this? Okay. I don't have a quick fix for this because I'm going to have to hunt through keyboard mappings essentially to try and fix it.
Okay. Try maybe Apple Watch on this option.
That's there, try that, sure.
Generic 105 key might be.
Generic?
Yeah, so try
That's not.
this with that.
Yeah.
not actually changing this at all.
That's also like a weird thing, like no matter which.
Try playing with it for now, just because I have a lot of stuff I need to get
Yeah,
through.
I
And then
know.
there will be a video recording at least. Yeah.
At least.
Yeah. Okay. I'm going back to my PDF file here. Here it is. Okay, it says try these next couple of commands. So I'll try that here just quickly. 3 times 4, 8 divided by 2 minus 3 times 4. So multiplication is the asterisk. It follows order of operations, like, well, depending on where you're from, it's slightly different. I call it BEDMAS, you might call it BODMAS. Brackets, exponents, division, multiplication, etc. Right? So that's the execution order that it'll go through. Okay, so yeah, 8 divided by 2 is 4, minus 3 times 4 is 12, negative 8 checks out. I would be surprised if it didn't. Okay, now, in theory, as you're going along and trying some of these things, you're going to want to save what you're doing, as I mentioned, in an R script. So that's what this next set of items is suggesting you try out. So what I'm going to do to create a new R script, this symbol on the top left, it's a piece of paper with a plus sign, is to create a new file, and I'm going to do new R script. It'll open a new pane in the top left. Okay. Notice it says untitled 1. This is a file that has yet to be saved anywhere. It's just a text file in memory. What I typically recommend doing is at the beginning of every R script, you're going to want to provide some metadata, some explanation of what the file's about. Okay. The way you create a comment in R, a comment again is something, it's a line that is not an executable line of code. It doesn't do anything. It's just textual description for human understanding. You use the hash symbol. Okay. On my keyboard, it's over the 3. Hopefully you know where it is. It looks like this, okay? It'll change the color of the text to green. That's how you know it's now identified a comment, and whatever's on this line will not be executed by R. So I'm gonna give it some info like my name. So author is me, the date, January 13th. Maybe what class was this? And subject, I'll say lab 1. Okay. Now if I want to save my R script at any point in time, I'm going to click this disk picture here. You'll know it's not, your file currently has contents that have not been saved to disk yet if the title shows up in red like this with an asterisk. Okay. So I'm going to click the disk. I'm going to navigate to that shared folder, or the folder I just created, this Business Analytics folder. And I'm going to name it something, like My Lab 1, for instance. If you haven't caught up with me on the comments and description of the metadata, it's not a huge deal. I'm just giving you an example. Once I save the file, notice that the title has changed from red, it's gone back to black. It means this thing is current, it's saved to disk now. Okay, so if I want to save some text or some analysis that I've been doing, for instance, I want to save this command, 8 divided by 2 minus 3 times 4. First thing I'm going to do, I'm going to have a comment that explains what I'm doing. So this is, for instance, question 1.1 hyphen 1. This is again a comment. And I'm going to now put the command here. Again, 3 times 4, or sorry, 8 divided by 2 minus 3 times 4. Okay. I'll save it. And now if I close R, notice this file that I've just saved, it appears in that folder on my desktop. So I have my work saved for future reference, right? So If I close R and I come back to R, I can open that script and go back and continue what I was doing. Here it is, mylab1.r. This is just a text file that includes what you see in the window there. If I want to run a command directly from a script rather than on the console typing it out myself, I just put my cursor on the relevant line and then I'd hit Control Enter at the same time. It'll copy the command to the console and execute it. You notice it skipped the comment. It pastes it to the console, but it doesn't do anything. And then it runs the next command for me. Okay. Any questions about that? Yeah. Do you have a question?
Go slower.
There's a video recording too, yeah. But I'll try and slow down a bit. Yeah. Okay. So, referring to the lab instructions. So we've done this first part. We run a few mathematical commands, so we know how to paste them into a script and how to save that script and refer back to it later. We know we can run those commands directly from the script by putting my cursor on the relevant command in the script file and hitting Control Enter. Okay. All of this stuff is showing you how if you close it and reopen it, you can get your script back. We know that works because we've just talked about that. And I'm explaining here, how do you create a comment? You know how to do that. That was the first thing we did. Okay, so that's section 1.1. Now we're going to go to section 1.2, which starts to discuss some more advanced mathematical functions. You might use some of these things to transform your data, for example, right? If you wanted to take a logarithm or an exponent or something like that, or a square root. This is what we're going to do next. Notice we've also got our first question in red, which means I'm not going to answer it for you. That's one for you to handle on your own. All right, so first thing, try the following commands. Square root of 16, 16 to the 0.5. This is the caret, which is above a 6 on an American keyboard. It may be somewhere else on yours, but it looks like a little arrow hat. That's an exponent, so 16 to the 0.5 is 16 to the 1/2, which is the same thing as the square root of 16. Right? So I'm going to try these out. I'll just put them into my script file. So again, I'm going to comment this. This is question 1.21. And I'm going to try square root of 16. Command enter or control enter is 4. That checks out. 16 to the 0.5. So this is the square root again of 16, should give me the same answer. Okay, and then the prompt is asking you, how would you calculate 4 cubed? Okay, so what I suggest as you're going along, I would say homework 1.21, or you label it however you want, as long as it's intuitive to you and you can figure it out again later when you're putting it into like a document that you're going to submit. And you're going to type the command here, okay? Question 1.22. Try these commands with the logarithms. So if you're not familiar with what a logarithm is, it's not super important actually. It's just a mathematical transformation, as long as you understand that much. So log, if I just type log of something, this is log base E, Euler's number. If I type log 10 something, it's now using log base 10. Again, if you know what logarithms are, this will make sense. If not, don't worry about it. This is not a class about logarithms. Note that the inverse of a logarithm is the exponential function. So this third one, exp log 1000, should just do the transformation and revert it back. See, just give me 1000 back. It's conducting the function and then inverting it again. So you can try those commands out. Here's a log base 2 with the input is 64. Okay. Now if I want to know what a logarithm is, let's say actually I don't know what that does and I want to find out. This is how we reference help files in R, right? So there's a help file for every function, which will explain what does it do, what are the input arguments you need to pass to that function, generally, for it to work, and what kind of output should you expect. So if I want to see the help file for the log function, I can type $log. I can put it on my my script as well if I'd like to. And I run this command. And in the bottom right, you see a help file open. Okay, logarithms and exponentials. I'm zoomed in a lot, so it's hard for you to see, but it walks through and explains what does a log do, what's that function for, and how do you use it. Okay, they give some examples about how you would use it, right? And I explain every input argument you can pass to this thing. Sometimes arguments are required. So if you don't pass a certain argument when it's required, you're going to get an error message. Other options or arguments are optional. If you don't provide them, it'll populate a default value for you, and you won't get an error message. Now, single question mark tries to load the help file for the name of the function that I passed. So $log will try and find a help file for log. Sometimes we're working with functions that come from packages that are not built into R by default. So they're third-party packages that somebody out on the internet has written, and you've installed them. We're going to work with a lot of those in this class. And using a single question mark, it may not find the thing you're looking for automatically. A double question mark is essentially going to do a keyword search through all the help files. Question mark log. So it's going to take a second, and it comes back with search results. And you're going to see a bunch of different things. Vignettes are extended examples. I don't know what Bradley Terry is, but that's another function that I've never used before, which makes reference to logs. That keyword showed up in there. Okay, so you're going to see a whole bunch of results here that are relevant to that keyword. Yes?
Well, my question's not like processing all the commands.
What's happening?
Pressing shift enter.
Not shift enter,
Oh.
control enter.
Oh.
Yeah. Or if you're on a Mac, command enter will work too. Any other questions? Okay. Okay. So there are also some mathematical constants that are baked into R, so it knows what pi is, for example, right? 3.14156, whatever. That's where I forget digits. So let's try typing pi here and see what it gives back. There it is. 1593. See, I was wrong. I don't even know as many digits as I thought I did. So if I want to calculate, so there's a round function, which is going to truncate decimals. So round pi gives me just 3. It rounds it down. I can round and tell it, notice I need to give it at least one argument, which is what do you want me to round off? And then I have optional arguments, for example, digits. So it's going to round it off to 4 digits. If I don't tell it what to do, it defaults to just getting rid of all the decimals. Truncate does something similar. TRUNC is the truncate function. Okay. Don't worry, I'm not expecting you to memorize all these mathematical functions because you're actually not going to need them necessarily. I'm just showing you examples, okay? So don't worry about memorizing this. Okay, 1.2 question 5, again, is a homework question. So there's a sine function, a cosine function, so you'll need to figure out how do I calculate these. Okay? Any questions about mathematical functions in R? Or even more basic questions, if something's broken and not working for you? No? Okay. Okay, now we're going to start doing some stuff that's more relevant to what you're going to do in this class. We're going to build some variables, all right? In this case, vectors. So I'm on question 1.31. So we're starting to work with vectors here. So this first command, I have x followed by a left arrow and then a hyphen or a dash. I'm assigning a value to x. So that arrow says take what's on the right and put it into x. And x is now going to be a variable in memory that I can reference and work with. It's like a data set. Okay. So what I'm populating x with here is a list. C is short form for concatenation, so it's a set of values. Okay, so I'm making a list with 3 values in it: 3, 6, and 8. Right? So it's a vector with 3 elements. Vectors, typically what they end up being is a variable later in a data set, right? You can think of this as a column in a data set. So I'm going to run this command. It executes, and the way you see that you now have X in memory is in the environment window in the top right, we have X. This is a list of 3 values. They're numerical. NUM is short for numerical, 3, 6, and 8. I can now do things to that, right? So if I just type X, it'll print the contents of X out back to my console for me. Okay, there it is, 3, 6, and 8. If I apply mathematical operators to X, it's going to do essentially matrix calculations, so element-wise calculations. So if I say X divided by 2, it's going to divide every value within X by 2, and then that's the new vector that it will create. So X divided by 2, see, it divided each value by 2, element-wise. I can take the exponential, so I can square it. Right, all the same stuff we were doing before, the square root. Okay. I can also reference specific values of the vector with indices. So the way I give an index, it's in square brackets. Okay, so again, we have X as this string or this list of 3 values. So if I want the second element of X, the 6, I can use indices and ask for the second element of vector X. So X, if I type left square bracket, R automatically guesses that I'm going to need a right square bracket, so it puts it there for me. And then it wants to know what's the index that you care about. In this case, the second element. Okay. When I run this, it gives me back that element at 6. Right? So I can ask for specific components of the data set that I've created that way. There are a lot of different ways that you can reference elements of vectors, or eventually we're going to get to the point where we have many vectors stuck together, and you can reference a vector with certain notation, so this will become pretty important. Okay, so this is how I get to the second element of a vector. I can also reference other elements, so if I say X and then I pass it a list, essentially it's saying X with indices that are comprised in this list, so x1 and x3. It's just going to give me back elements 1 and 3 of the vector, not 2. Let me try that out. So x, square brackets for index, elements 1 and 3.
One question: why could you just not like put 1, 3 in like brackets without the C? Why do you have to put a C?
So yeah, so the question is, why do I need to pass a list? Why can't I just say 1, 3? The reason is that notation actually means something different. That's for matrices. When you talk about a matrix, indexing a matrix, you have to pass 2 values, typically, to get 1 back. The first value is what row, the second value is what column. So it'll give me an error message saying there's only 1 column. It doesn't know how to interpret that index for a vector, which is just a single column. So you have to pass it a list in this case. Okay. I can ask for X, and if I put a minus in front of this, that's another way of saying everything except this. Okay, so I can say X minus 3. It gives me back 1 and 2. I can do the same thing with lists. So I can say X minus 1 and 2, and it gives me back the third element. Okay, so you can work with specific values and their complements as if I put a minus sign in front of this. Yes?
Is there a way to index the final element and how long the list is?
There probably is. Let's see. So yeah. So the length command for a vector is how many elements are there. So if I say X, give me whatever the total number of elements is, that'll be the last one, for instance. There's other commands you're going to come to. So length tells you how many elements are in a vector. There's a function called nrow, which tells you how many rows, which will probably work here as well. Yes?
Why is the length how many elements? Aren't there only 3 elements?
Yep. So I said X, and the index is the length of X, which is 3, and it'll be the third element. We'll come back.
Oh, okay.
But then if we didn't know that there were 3 elements, we wouldn't know
no matter what, if you type length of x, it'll always give you the very last element.
The last element.
Yeah.
No matter.
Okay. Any other questions?
So how do you, like a function where you count like how many elements there is?
No, so length will do that for a vector.
Uh-huh.
It tells you how many elements are in the vector. If you have a matrix, you can ask for n row, which is the number of rows in the matrix,
Mm-hmm.
or n col, which is the number of columns,
Mm-hmm.
if you want to get to the last one. If you wanted to do that for some reason. Yeah. Okay. I'm going to create another vector to work with so I can do operations on combinations of vectors. Right, so I'm going to make y. Let's say y, again, left arrow with a hyphen, so I'm assigning values into y. You can actually use an equal sign too if you prefer to do that. It'll do the exact same thing. So I can say y is equal to 2, 5, 1. Okay, and now I've got y in my environment window also. So I have these two vectors that both have 3 elements. Okay. So left arrow with a hyphen or an equal sign, they're equivalent. So I can print y out again to the console just by calling for y. And now I can actually do vector addition, vector multiplication. So I can say vector x minus vector y, right? So again, minus is the hyphen sign of the dash. So it just takes element y as first element, minus first element, second element, minus second element, right? I can multiply them together. Again, it'll do it 1, 1, 2, 2, 3, 3 element wise. Okay. And now we can get to some, I don't know, other interesting ways of indexing a data set. So again, I use square brackets if I want to index. Here, what I'm going to do is I'm going to say, give me back all the values in x using the indices from y, where the values of y are above 1.5. So it assumes, right, so essentially it's going to work from the inside out, right, just like BedMath. So it's going to first figure out y greater than 1.5. That command is going to give me back a list of values, which were the indices of the elements of y, were the values above 1.5. Okay, then it's going to use that list and index x and spit back the values from x that are associated. So if you think about these as being two vectors that are side by side, it's going to figure out the rows of y that meet the condition and then pull back. It's like a VLOOKUP in Excel if you're familiar with that. Similar idea. So I'm going to say x, square brackets, where y is greater than 1.5, whatever those element numbers are. Okay, so it gave me back 3 and 6, which are the first two elements. If you look at y, values 2 and 5 are both bigger than 1.5, so those are the associated values that spit back for x. 1 is not, so it didn't give me back the 8.
Can you see that again?
Yeah, so we have these two vectors here, right? So we have x is 3, 6, and 8, and I'm querying x, and I'm saying, give me back the values at what indices? The list of values where the y value is greater than 1.5. So what it's going to do first is figure out what is this list. It looks at y, and it comes back with the indices of the elements where the value is bigger than 1.5. Index 1 and index 2, if this is true for both of those. Index 3, it's false, so it doesn't return that value back. So it knows 1 and 2 are the values it's going to index x with, 3 and 6. Okay. And you can get as complicated as you like with a lot of this stuff. It really depends on what you're trying to accomplish. It's kind of as flexible as the regular programming languages in that sense. Like, there's a lot of different ways to accomplish the same goal. I can say, give me the values from y using the indices of the elements of x that are equal to 6. So if we look at 6, or we look at x rather, 6 is element 2. So it's going to return back that value, right, for the index, because it's going to say x equals 6. That is index 2. It's going to return back 5 from y. So y, where x is equal to 6, gives me back the 5. We've been doing a bunch of stuff here. Hopefully you've been saving your commands in the R script. I'm just going to save this thing. Again, if you want to remember it later or go back to it, you want to save it in your R script. Okay. These are practice questions, by the way, and there's a video you can refer to I hear panic here. So I'm gonna just save this, right? Just to keep it up to date on my disk to make sure everything I've been doing is stored. You'll want to keep doing that as you go along. Now, how do I get a sequence? So I can get a sequence of values or a list. So 4:10 is going to give me the sequence of values between 4 and 10. Yes.
You want to explain the difference between the double equal to and single equal to?
So we use single equals to assign a value. A double equals is an if, it's a conditional, it's a logical test. It's saying, is this equal to that? It'll spit back a 1 if it's true and a 0 if it's false. Okay, or in this case, when I'm using it as an index, it's going to spit back the values where it's true, a list of them. Okay, same with the greater than sign. That's a logical test. It's going to give back the indices where this condition is true. So just coming to these sequences here. So if I type 4:10 on the console, it gives me back the sequence of values between 4 and 10. Okay, and it guesses that I want integers because I didn't have any decimals in my query. I can also just call the sequence command, which is essentially what that earlier command just did, right, in the background. I can say a sequence from values 2 to 3 and increment by 0.1. So it'll go 2, 2.1, 2.2, 2.3, all the way up to 3. Okay. I can also use the repeat command. So it's saying repeat values in X. Do each one 4 times. Okay. So again, the main thing to keep in mind is that the way vector operations generally work, it's element-wise. So it does each thing one by one, once for each element. Okay. We're now getting to another homework question where you need to use the stuff that I just explained, right, to try and answer this question. So it's about calculating body mass index for a bunch of people. So say that we have 4 people that we've collected data on. We know their height in centimeters. It's these 4 values. And we know their weights in kilograms. It's these 4 values. So the first thing you need to do, make a vector for each one of those groups. Right? So each one of those groups of values. So we're going to have a vector for height and a vector for weight. We're going to call them height and weight. Now what we need to do is create a third vector, which is the calculation for BMI from those 2 vectors. Okay? Right? So you're going to, again, you're going to be question. So we're on question 1.32. Right? This is a homework question. Height is equal to, I'm going to give it my set of 4 values for height. 180, 165, 160, and 193. Okay. So that'll create the height vector. And then I'm going to do the same thing with weight. 87, 58, 65, and 100. Okay, and now I need to do some, there's some vector, there's an exponent in there, there's vector division, right, to calculate BMI. So basically you need to figure out what is the operations that I need to do with height and weight to get BMI back. Be careful here. This is in centimeters. Note that this is in meters. You're going to get weird values back if you don't pay attention to that. Okay. Now we're going to do some simple summary statistics. Okay, so assuming we have a data set, we can do things like sum the values, calculate the average value, the median, things like that. So we're going to be on question 1.3. Sorry, 1.41. And so the first thing we're doing is we're creating a vector of values that we're storing in a column called dry. What's the background here? An experiment where dry weight has been measured for 8 plants. So I'm going to create that vector of values 68, 88, 75, and 100. Okay. Okay, and there's the set of values, right? So we know it's stored properly, and you'll see dry is up here in the environment window. Now, first thing I'm going to do, I'm going to sum all the values in dry. So it's going to add them all up for me. 593. I can get the length of this vector, as I showed you earlier. It has 7 elements. I can get the mean, right? The arithmetic mean of all these 7 values, like so. Right, 84.7. I can do some vector addition from 2 calculated values. That's what this next command is going to do. So I'm first going to calculate, I'm going to sum the values in dry, and then I'm going to divide them by how long is this, which should give me the same answer, because that's how you calculate a mean. Right? Works. Now I can try the sort command. So the sort command is going to reorder the vector, right? The values in it. I think by default it's going to be ascending order. Yep. Okay. But I also suspect there's a way to make it descending. Let's make something up. I've never done this before. It probably won't work. Nope. So I'd have to go to the help file to understand how sort works. So here's the sort command. Here, decreasing equals false. So I typed descending, I was close. So sort dry decreasing equals false. Let's make it true. Okay, so then it does biggest to smallest. And then if I want the median value, right, I can do this, median of dry. And 88 is the median value. We have some other functions here. So we have SD is short for standard deviation. We have VAR is short for variance. You can calculate the standard deviation of dry and then take the square of that value. That's what this will do. And we're taking the summation of a bunch of vector manipulations. So we're subtracting each element of dry. We're taking away the average value squared. Sorry, we're taking away the average value. I think we're calculating variance here, or standard deviation rather. I'll just try one of these for fun, why not? You'll notice if you try and cut and paste directly from the PDF file, you're probably going to get into problems pretty quickly because things don't copy over correctly. So I wouldn't recommend doing that. Like notice it's not highlighting the hyphens for me. So if I take sum of dry minus its average, right, so this is sum of squared errors essentially, divided by the length minus 1. I need a couple more parentheses here that I'm missing. Okay. This is what it gives me back, which I suspect. Yeah, there's the variance. Okay, we can get a minimum value this way, a maximum value this way, min and max. So the minimum value in dry is not the index, it's actually the minimum value, right? Or the max. And then the summary command is one you'll use quite a lot, where it just gives you summary statistics. Okay, so it's giving us the minimum, the median, the mean, the max, third and first quartiles. Okay, it'll show you something else if it's not a numeric vector. characters you see other things, like how many times each unique value appears, stuff like that. Okay. Any questions so far about that stuff I was doing? Because then you're getting to the next set of homework questions. No. So this first question is asking you to do conversion between Fahrenheit and Celsius. I've given you the equation, so kind of like the BMI question. You have to create a vector of values, which is the values in Celsius or centigrade, and then construct a new vector, which is the Fahrenheit vector, that contains the correct adjustment. We have a question here for calculating the volume of cones, and I've given you the equation again. Right, so you have a radius and you have a height for a whole bunch of different cones, and you're going to calculate a vector, which is their volumes. And then I want you to calculate the mean, the median, the standard deviation of those volumes. And then there's also another question where I want you to give me the mean only of those cones where the height is below a certain value. Okay? So we've gone over how to do all of that with indexing earlier. Any questions? No, things are clear. Okay. Any questions?
Let's see about
Let's
that.
see. Again, there's a video you can go back to. You're working in pairs. You can ask me questions on Slack. Right. I'll answer. So I've already gone through how you get to help files. I have a question here where I'm basically saying open the help file for this function. And I don't know what it does actually. I suspect it's going to give back an index of the minimum value. But I would just type this in, get the help file, and then in your own words in 1 to 2 sentences explain what it is. Basically, I'm just forcing you to try help files. Yes?
And then if you want to know, like for example, how we calculate, for example, the standard deviation,
Mhm.
in the console we have to type like the question mark, but we're not going to type standard deviation, right? There is a short name for that.
It's SD in this case, but if I type, let me see what I'm allowed to do here. I've never done this before. It does a search. What does it come back with? So it did a search with this whole, like I put in quotes, double quotes, what it is that I'm looking for if I don't know what it's called, and it runs a search through all the help files for the word standard deviation together. And it'll give me back a bunch of results here. For this kind of thing, what you're working with, it's probably going to be in the base package. But you could go through this list of things that it spits out.
They're a list with all like the standard functions.
So here's this is one sec. There's a psych package, for example, that's not installed here actually,
Okay.
that has a standard deviation function you could use. Here it is, stats. This is the one actually that I think we have been using.
Okay.
It's in the stats base. So you could do a general query like this. You could also just go to Google, right? So I could just open up Google and say, how do I calculate standard deviation in R? Standard deviation, R tutorial, right? You're gonna find people on Stack Overflow answering this question here, SD. Okay. So I would go there first actually before I would go to the help files if I don't have an idea what the function is called.
It's
Okay.
faster this way than
It's going to be faster this way, yeah. Yeah. Any other questions?
Is there a list with all like the say functions and commands that we have where we could just look it up and see maybe okay we find it there?
Can you go on internet?
So there's the lab solution
Uh-huh.
that you can refer to where I've given the commands in an R file for you already. You can check it out. The other thing you can do is watch the video, right?
Yeah, no, just if in
Yeah.
the program there's a help file where they list all the commands.
No, the reason being that there are literally millions.
Okay, fair.
Yeah. Yeah.
Okay.
Any other questions? The thing you're going to encounter, actually, there are certain functions that have been implemented more than once in different ways by different people in different packages because they're just not aware of what other people are doing. So, okay. So assuming you've done this part where you're trying out the which min command or you're looking up its help file to see what it does, you can also try running it this way. So I'm doing what I told you shouldn't do a second ago, which is copying. Oh, I can't copy and paste like that. So we're not going to do that. I'll just type this in, which.min, and I'm going to pass it as input a list of values 2, 5, 1, 7, and 8. And it gives me back 3. Why did it give me 3? Yeah, it's the index of the minimum value, which was my guess. Yeah. Okay, so this is how it gives you back the index of the lowest value. All right, so if we say which max, it should give us back the last value. By the way, if you want to edit a command you just typed on the console, maybe you had a typo in there or something, and it gets annoying because it's a really long command and you have to type it out again. You can actually use your arrow keys up and down. The up key and down key go through your buffer, so commands you've recently run. Okay, so I can go up and down. If I go up to my last command, I can just edit it to say give me the max. Okay, and index 5 is the maximum value. The buffer becomes pretty useful.
In your second vector, there are 2 ones. If you go which min with 2 minimums, it picks the first min.
Which min? Oh, this one does, yeah. So I edited this slightly, you're right. So if I do which min, I guess this is good to know. It'll just find the first value that matches the request. So there's actually 2 values that are tied here, and it just gives you the first one.
Sorry.
So it's running which min, and there's 2 values that are equal, that are both the minimum.
Like with the up and down keys to go through recently used commands, it's called buffer, right?
It's the buffer, yeah. Keyboard buffer. Oh, so here's this question that we just were at a second ago. So what do I do if I don't know the name of the function? Yeah. So you can do a single keyword search this way with a double question mark. Apparently, I just found out that you can put double quotes around a set of words if you want a sentence or something. Yeah. You can run this if you want. It's going to give you a whole ton of results because lots of things mention regression. Okay, so double question mark followed by the keyword you care about. We'll bring you to the help file. Okay. We have 20 minutes left. So I'm going to pick up the pace slightly. So we are going to now read data into R. So Section 2. We can read CSV files and Excel files in different ways, actually. So again, a CSV file, .csv, is a comma-separated value file. What I would suggest if you want to see what that looks like in its raw format, go to the folder where we saved our files earlier, and you have cherry.csv here. You can open it with OpenOffice, or you could just open it with, do I have something easy? Mousepad. I right-clicked it and chose Open with Mousepad. Just a text file. This is what it looks like. Okay, so the first row is column names. And actually, this is called a comma-separated value file, but it's not comma-separated. It's actually semicolon-separated. Okay, that's important to know, because when you read the data in, you need to tell it the right separator character. Okay, so we have girth, height, and volume. So I'm going to go back to R. There's a number of ways to read data in, as I mentioned. Did I close this? Yeah, I'm going to go back to my lab solution. No, we're not. There it is. Okay, I'm just bringing my script back. So the easiest way to read data into R is to use the import dataset menu. Okay, I can click this and I can either get it from base text, just means it's a text file. Okay, this is fine for comma separated values. Reader is another package which is a little bit more, it has more functionality in terms of it's a cleaner import interface. It shows you this is what the data will look like if you use these settings, that kind of thing. Excel is for Excel files. SPSS, SAS, and Stata are other software tools that can read data from those other tools, native formats also. So I'm working with the CSV file. I'm just going to import from base. And then it wants me to navigate to where the file is located. So desktop, here it is, cherry.csv. Okay. It shows me on the right what the file looks like, so I know what I'm doing. So I know, for instance, yes, there is a heading. Variable names are the first row. That means heading should be yes. The separator, it detects and guesses that it's a semicolon. I could change it to be a comma, and it will import all of that data will be one value, right? And the name of the variable will be girth, semicolon, height, semicolon. It'll mess up, obviously. So it's a semicolon. How are decimals recorded? They could be a comma. They could be a period. Make sure you're paying attention to what's in your data. And then these other variables or these other settings are about if I'm dealing with strings. So how are strings or characters mentioned in this data set? Are they in double quotes or what? It's not relevant here because we don't have any.
It's giving me our code error.
What is the error message?
I mean, I know the code to, like, I'm using that import data set now.
Yep.
Now I can just copy, I already have the code from another project. There's an error.
Okay.
It's our code execution. I think it's what happened last time to us is that babies are like that when they have to be the opposite way, like fast.
Could be. I'm not sure.
I think
So
it's that.
are you just going through the import?
Yeah.
Cancel.
And you might be.
And then make sure you use the CSV file.
I didn't know that.
It's just too much.
Or
Could be.
by accident.
Yeah, it could be.
I know how it is.
So yeah. Anybody else getting errors when they do this? No. Okay. So this is one way to do it though. Okay, and my window is kind of small, so I can't see everything I'm doing, but if I just hit enter, it's going to do what I asked it, right, with those settings. And here's the data. It automatically opens it for me. View. And here's the data in the top right in my environment window. 31 observations of 3 variables. Okay. I think it's a bunch of cherry trees, and it's their characteristics. So how wide is the trunk, how tall is it, and what's the volume? Okay. So I can close this view. And I'm just going to go back to my instructions. So that's one way you can import data. The second way you can import data is you can just, now remember, you need to have a variable in your memory, in our memory, to contain whatever it is you're reading in, right? So just like we created a list of values and we stuck it in X, you need a name for the, it's called a data frame in R. It's kind of a spreadsheet essentially. So I can say, you know, whatever, cherry 10, I can assign it a value. And what am I going to assign it? Well, I'm going to read data from my hard drive. So read.csv is the name of the function that it called when I went through the menus, right? And I can, instead of giving it a file path, I can just type file.choose, open and close parentheses. That's the name of a function, file.choose. It doesn't require any arguments. What it does is it opens up a browser window on your hard drive, okay? And I can pass some other arguments here, like I can tell it headers equals true. Well, doesn't need that. Maybe it's singular. Yeah. And when I run that command on the console, it's going to open up the file browser window. I can navigate and find the file. And then it'll rerun the command with the file path, the text file path populated to read the data. And it'll store the result in Cherry 10. Desktop, business analytics, the CSV file. Okay. And here's Cherry 10. It's the same data. This one didn't read properly, notice. It thinks there's only one variable. Why? Anybody know? Yep.
Probably because it guessed comma as a separator.
Yeah. So the interface-based one on the graphical user interface, it guessed correctly. I'm not using that interface now. I'm using read.csv function directly. It's not as intelligent. It doesn't guess. It just assumes comma, and it's wrong. So because it doesn't see any commas, it thinks everything is one value. So what I have to do is I have to try it again, and I modify it. I add a new argument. SCP is short for separator. It's equal to, I have to put quotes around this because it's a string, and it's a semicolon separator. I would know that because I would have opened the file already in a TextPad or something and seen that. So I'm going to run this again. It's going to overwrite Cherry 10 with this data and replace it with whatever happens this time. Find the data. Okay, there it is. It worked properly this time. We have 3 variables. And I can make sure of that with the view command. View is going to say it takes data frames and it opens them up in the top left and like in a spreadsheet format so I can look at what it read in. Okay, here it is, and we see it's read properly. Again, by default, it assumes decimals are periods. If it's a comma, you need to tell it that. The argument is DEC is equal to, and then in quotes you would put a comma instead of a decimal. Okay. There's a few commands that are listed here for how you can play with data to inspect it after you've read it in. So head gives you the first few rows, the first 5 rows. Plot will try and guess a visualization for that data. In this case, by default, it's going to guess because it sees a bunch of numerical values. It'll make a scatter plot. So I'll just show you what that looks like. So if I say plot cherry, it creates a plot in the bottom right. See? So this is a bunch of scatter plots. Because there's 3 variables, it creates a scatter plot is x and y Cartesian coordinates, and puts a dot for every unique value in the data set. And because there's 3 variables, it makes 3 scatter plots. So A with B, B with C, A with C, right? So it's all the pairwise. And they're symmetrical, so it's basically like a correlation matrix. So the top right 3 scatter plots are identical to the bottom 3 on the bottom left, right? So I know this is girth by height, this is girth by volume, right? So that's the default that it guesses I want to display. Okay, so I'm just going to close this. We can then summarize the data set with the summary command. So I pass it the whole data set, and what did it do? Some warning messages. Oh, it's giving me errors about my plot window because it's so tiny. If your plot doesn't display properly, or you get errors and warnings like that, you can make the thing bigger and rerun the plot command, and it should solve your problem. I'm going to ignore it for now. If I scroll up, I do see summary statistics here, right, for the 3 variables in my data set. So min, max, mean, median, right, are all displayed here. Now, if something was read improperly, like if I didn't tell it what a decimal was correctly, it may, or if I give it something about the thing. So if I don't give it a comma, for example, if it's not comma separated, but the data is actually, I tell it comma separated, but the data is actually semicolon separated, it reads in a bunch of numbers with semicolons in the middle. That's obvious. It doesn't interpret that as a number, clearly. It'll interpret it as a string, text. So now I have one variable, which is comprised of textual values. If I call summary on it, it's not going to show me a mean, a median, and other things. It'll show me something else about how many unique values appear, etc. So if you run summary on the data and you get that back for a variable and you didn't expect it, it means it probably wasn't read properly by R. You need to go back and revisit how you read the data in. Okay. Okay, this is just going through if I made a mistake, how do I fix it, and then summarizing the data again. So this gets to this point about data types in R. Right? We talked last class about numeric data types, continuous values, ordinal values. We also talked about nominal data types, which is typically what happens when you have a textual value like red, green, blue, where there's no clear ordering to them. R talks about those as, it might be more familiar to you this way. It talks about integers, it talks about floats. A float is just a decimal value, or a double is also a decimal value. They also have strings or character types, right, which are for dealing with textual values. So you can see the data types of the variables that were read in. If you go to the top right window where your data exists in memory, there's a little blue arrow there that you can expand. And if you do that, what you'll see is it'll show you each variable and the data type will be next to it. So it calls the continuous data type here for girth as number or numeric. Height is an integer, right? Because it's always a round value. And then volume is again numeric. So if you instead saw CHR, that would be a string value, character. Okay. So this is again just showing you different ways of reading data into R. So now we're talking about how do I read data from an Excel file. So instead of a CSV file, we're now getting to XLS files. There's a function here I've given you called read_Excel, right? Which is actually, I think, what is going to be called if you go through the import menu and choose from Excel. Okay, you can browse and find the file. So in this case, I'm going to do cherry.xlsx. Okay, and it gives me a preview window here that I can't see because I'm zoomed in too much, but 3 data types, right? Girth, height, volume are all doubles. First row contains variable names. Open the data in a viewer once you're done the import, and it shows the command here that it's going to execute. So there's a library it's going to try to load because read_Excel is not a native function to R. There's the file path that it's going to go for. And again, I'm zoomed in, but I'm going to hit enter and just run this. No, I can't do that. Yeah, I need to resize this thing so I can see what I'm doing. There it is. So I have to click import here. Okay, it runs the command. It's giving me errors about my plot space being too small. I'm just going to clear this. And you see the same type of data as before. Just it came from an Excel file this time. Okay. We could open the file in Excel and we could save as and save it as a CSV file if we didn't want to have to remember this. Okay, you can always work with CSV files if you prefer that. So now we're going to try and play with this data a little bit. So if I wanted to inspect data, again, we use the view command, so you guys know how to do that. This is just giving you different ways of reading data in if you're encountering problems. So you can use different functions, you can open and save as a different file type. If it's not reading the data properly, you can open it in Excel or you can open it in a text pad and do like a find and replace to replace with commas instead of decimals or something, right? So you have all these options to play with if you're having problems reading your data in. Okay, now we're going to talk about how you work with variables in a data set. So I'm skipping here to section 2.3. And specifically, I'm going to look at item 2 here. So this is talking about using the $sign syntax to reference a column. Okay, so we're now working with a data frame, recall. So that's set up, it's rows and there's columns. Each column is a variable, each row is an observation. If I want to reference a specific column, that vector, I use the $sign. So I can say cherry $sign, and then look, R helps me. It pops up and gives me options to choose from. Okay, so it knows there's 3 values that I can choose from here. I'm going to say girth. Control Enter to run that from my script, and here's the vector girth. Okay. If I wanted the average value of girth, I do what I did before. I have the mean function, and I pass it a vector. How do I get that vector? Cherry dataset, girth column. Control Enter. Okay, so that's the mean value of that variable. I could also say summary of the cherry dataset, and it gives me summary statistics, and here's girth, the mean. That's another way I could get to it. I can also tell it, there's another syntax I can use instead of using the $. I can say with the with command, so with this data set, execute this, and it'll look for the variable in that data set. Okay, it's just another way of accomplishing the same thing. So I can say with the cherry data set, give me, hist is short for a histogram. It's going to draw a plot in the bottom right. So I'm going to make this a little bigger. So it'll take the cherry data set and it'll apply the histogram function to the height variable, and it'll look for that variable. Margins are not great. There you go. Okay, so it makes a histogram. If you're not familiar with histograms, it's density distribution. So essentially, like, how many values are there of each value in this data set? Right? The higher the bar, the more observations are in that bucket. So there's a lot of values between 75 and 80 for height. So the next question is just asking you to verbally explain your understanding of the difference between a variable and a data set and things like this. So I'm going to pass that. And the next is talking about how do we subset data and transform variables. And honestly, I think we're going to run out of time. So what I plan to do is finish this up in video format. What's the easiest thing? So transformation is just applying a log, and for instance, in this case, and storing the value. How do I do indices with a data frame? So as I mentioned earlier, if we have a vector, we just need one index. What element am I talking about, right? If it's a matrix or a data frame, I have to pass it two indices, row, comma, column. So I can say cherry, square brackets for indices, give me the third row, third value, so third column. It gives me the value here is 10.2, right? And that's the volume value for that tree. Indices work the same way otherwise, so I can pass sets of rows and sets of column values, and it'll give me everything that meets those conditions out of the data frame. We also have a subset command, which is specifically used for getting rows from a data frame, right? So I can give it a logical condition that has to be met. So give me this command, this subset command is essentially saying give me all the rows from the cherry data set where the height is bigger than 70. So subset of cherry where height is greater than 70. Okay, and it brings back all the resulting values that meet that condition. And I could store that output in a new variable, for example. Call it tall cherry trees or something. Okay, so I'm going to stop there. I'll record a video completing